Nike is a global leader in sportswear and athletic footwear, particularly renowned for its innovative running shoes like the Pegasus, Vaporfly, and Alphafly. The company consistently prioritizes performance enhancement and customer experience, ensuring that runners have access to high-quality products. However, Nike's current recommendation system for running shoes primarily relies on broad categories such as fit, cushioning, and shoe type. While these are helpful, this method lacks deeper personalization that considers an individual's unique running biomechanics. Some stores offer Nike Fit, which scans foot dimensions, but this service does not integrate running patterns or data-driven insights. This presents a clear gap. Nike has an opportunity to enhance its recommendation system by incorporating wearable fitness data to provide more tailored, performance-optimized shoe suggestions for runners. Nike's current shoe recommendation process relies heavily on broad categories. Customers either rely on in-store guidance or online filters that categorize shoes by arch type, terrain, or level of cushioning. While this does provide a general framework, it doesn't consider factors such as running efficiency, injury prevention, or gait biomechanics, which are key elements in ensuring the right shoe fit for each runner. The main goal of this process is to help customers find suitable running shoes, but without individual biomechanical insights, the recommendations may not fully optimize performance or prevent injuries. To address this, our proposed enhancement introduces data-driven personalization by integrating running metrics from wearable fitness devices. By analyzing real-time running data, such as cadence, foot strike, and terrain preferences, Nike can offer highly personalized shoe recommendations that improve both customer satisfaction and running performance while reducing the risk of injury. This approach strengthens Nike's position as a leader in sports science, which reinforces their commitment to innovation and athlete-driven product development.
To integrate data analytics into Nike, there needs to be a process change. So I want to discuss the before and after. The current process, we use customers select their shoes based on general categories, fit, cushioning, etc. And there is no integration of personalized running data or analytics currently in our model. So what I propose is after the data analytics are integrated, customers sync their fitness tracking data. They can use Garmin, Strava, Apple Watch, etc. And an algorithm that we create will analyze key metrics like pace, cadence, stride, length, foot, and strike patterns, etc. Within the Nike app that we create, it'll generate personalized shoe recommendations based on real-time and historical data for that customer. So what does this process change look like? Next, I want to discuss this process diagram. You have your input, collection, analysis, and output. This simple flow chart under input will show that customer selects a general category and customers sync fitness tracker data. That's the input. The collection is we are going to run metrics that include the pace, cadence, and stride that I spoke about in the last slide. Also, there will be an analysis of this data using an algorithm that evaluates biometrics and past performance. What does that create? Well, the output of a general shoe recommendation using the Nike app, it'll personalize shoe recommendations tailored to biometrics and performance.
The machine learning system utilizes a classification model with reinforced learning to recommend the best Nike running shoes. The model predicts the optimal shoe type based on biometric data, aiming to reduce injuries and enhance performance. By incorporating customer inputs and real-time analytics from fitness apps like Nike Run Club and other fitness apps, we enable continuous learning and improvement of predictions. This approach ensures the system adapts dynamically to user behavior, providing personalized recommendations that evolve over time. The integration of reinforced learning allows models to refine its predictions based on feedback, making it more effective in preventing injuries and optimizing user experience. The model relies on a variety of fitness apps and customer inputs as primary data sources. We use supervised learning with the target variable being the recommended shoe type. The feature vector includes essential biometric and performance data such as pace, stride length, and stride pattern. Real-time data streams from wearable fitness devices provide continuous updates, enhancing accuracy. Additionally, historical running logs data from applications like the Nike Run Club are used to improve long-term prediction reliability. This comprehensive data set enables precise and personalized shoe recommendations aligning with our goal of injury prevention and optimized running performance.
This new process will allow Nike to measure key performance metrics, starting with customer satisfaction scores, allowing improved feedback focused on shoe comfort and performance. Injury reduction rates, focusing on the decrease in reported injuries due to improper footwear selection. Conversion rate improvement, displaying the increase in purchases following app-based personalized recommendations. And algorithm accuracy, based on the percentage of correct predictions based on user feedback. When it comes to workflow impacts, affected participants would be customers who would need to sync their fitness tracker data to receive personalized recommendations. Following, store employees and customer support teams who may require training to assist customers in understanding the new app-generated suggestions. And finally, data scientists and developers who will need to focus on continuous algorithm improvements and model refinements based on users' feedback and performance metrics.
So, how do we go about testing the improvement that we've proposed? Our hypothesis says that personalized shoe recommendations can reduce injury rates and improve customer satisfaction versus generic recommendations. So as our control group, we'll use customers who are using the existing recommendation system. This is a system that does not have personalization. Our treatment group will be customers receiving AI-driven personalized recommendations, and this will be in the form of types of workouts, types of apps they're using, along with other data that we're gathering. So our sampling technique will consist of random sampling of Nike app users who give us willing consent and would like to participate in the sampling process. And this is how we will go ahead and test our improvement. Some additional considerations that we have to take into account is data privacy. To do this properly, we must implement strict security protocols to protect sensitive fitness data, user data, and abide by all privacy standards in the US. Another thing is our user experience. We need to give clear instructions for syncing different devices and using the recommendations to minimize friction for onboarding users and continuing user groups. And last is scalability. How do these systems need to grow and adopt more users as wearable technology continues to grow